Assalamualaikum warahmatullahi wabarakatuh. Today I would like to present about the Tata High Voltage Engineering project, which is group assignment. Okay, first of all, I would like to introduce our group members, which is me myself, Adib Nur Hazim bin Mustafa, and my matrix number is CE190169. And next is Hanif Hakimi bin Azlan. The matrix number is CE190063. And next member is Muhammad Azizi bin Mizan. The matrix number is CE190074. And lastly, Muhammad Hanafi Adli bin Ahmad Sobri. The matrix number is CE190071. Okay, next. Okay, the company background. Okay, this is our company logo, which is our company name is Light Up Sdn Bhd. Okay, Light Up Sdn Bhd began operation in 2022 and now employs 4 people. It's made up of the following individual, which is President, Vice President Human Resource, Vice President Finance, and Vice President Marketing. Light Up Sdn Bhd is a Batu Pahat-based Bumiputra engineering enterprise that is new and rapidly developing. A vast number of professional business, government authorities, and internal consultants in relevant disciplines have incurred a positive impression of the company. Light Up Sdn Bhd developed and produced high voltage test equipment that is extensively used and trusted by utilized and contractors all over the world. Okay, next, the staff organization. Okay, this is the staff organization. The Light Up company is have 4 people involved, which is Hanif Hakimi bin Azlan as a president, me myself Adib Nur Hazim bin Mustafa as a vice president sales, and next is Muhammad Azizi bin Mizan as a Vice President Production, and lastly Muhammad Hanafi Adli bin Ahmad Sobri as a Vice President Finance. Okay, next, the introduction of this project. Okay, the introduction. The transmission line is a long bundle wire that transport high voltage energy from one station to another. Consider voltage drop, transmission efficiency, and line loss when constructing transmission line RL and C. Resistor, inductance, and capacitor affect these values. Two transmission lines exist. Electrical insulators separate conductors from one another and surrounding structures. They restrict current flow to wires or other conductors by separating electrified circuit parts. Okay. It basically is explained about the transmission line, and is explained about the insulator. An insulator stop current passage from the pole conductor to the ground. Transmission line must work. Insulators may be made from rubber, wood, plastic, mica, and etc. This is the insulator. The material that used for the insulator is the example, and porcelain is the most common insulator material. However, stator and glass are sometimes used. Will create our company create a 132 kilowatt insulator model and use FEMM to simulate and assess its normal voltage and electrical magnetic field distributions. Okay, next, the problem statement. Okay, this is the problem statement, which is transmission line employ 3 or more conductor to transfer high voltage electricity over a long distance. A conductor transfer electrical energy is important for above and below ground electrical transmission and distribution. Transmission line losses include energy, magnetic, and electric. Okay, next, the insulating support links the electricity line to the utility pole and tower. They support the line without allowing electricity to flow down the tower. Insulation engages nearby residents, fluctuation, material stability, and this project, oh, this group assignment is to design an insulator model that is suitable for 132 kilowatt or 275 kilowatt by using drawing software. And also to simulate and analyze the insulator model, normal voltage and electric magnetic field distribution by using FEMM software. And lastly, we are able to work effectively in a group to tackle complicated high voltage technical challenge in a timely manner. Okay, next, the scope of work. Okay, this is the scope of this project. We need to draw and design of 2-dimension and 3-dimension insulators by using an AutoCAD software. Next, we need to simulate the high voltage and electrical magnetic field distribution by FEMM software. Next, we also need technical analysis insulator design. HV insulator can withstand up to 132 kilowatt. And lastly, the scope of work is the fitting used for the HV insulator is caps and pins. Okay, lastly, we explain about the outcome of the early work. Okay, we have 4 points here, which is to understanding the design and the material of high voltage insulator models by considering appropriate method endorsed in the formal literature. Then determine the appropriate material for high voltage insulator models. Next, using the FEMM software to analyze the insulator high voltage and electric magnetic field distribution. Lastly, the company will analyze their findings in both writing and oral formats. Okay, that's all from me. Thank you very much.
Assalamualaikum. My name is Muhammad Azizi bin Mizan. My CAD number is CE190074. I will continue for the 3D drawings. This company used the AutoCAD software to design the porcelain insulator for the 132 kilowatt transmission. This company designed this type of insulator using criteria that discovered from the research paper and the information on the internet. The material has also been investigated in order to make this insulator suitable for the 132 kilowatt transmission line. As you can see, this is the picture of our insulator. We're using the porcelain and the conductor is steel. For the insulator specification, the nominal clippage coupling our insulator is 330 millimeter. The minimum fan load 70 kilonewton. The combined electromechanical strength 90 kilonewton. The diameter oscillating 2.5 milliamp. The drive power frequency flashover voltage 25 kV and others. So for the performance and properties, quantity of porcelain cap and pin that required for system voltage at 132 kV. Our project using 11 kV per disk, which is the total disk we using is 12. The arching horn and grounding ring that attach to insulator. The arching horn and grounding ring will be utilized to prevent the insulator in the event of flashover from being damaged or cracked by the arc heat. Suspension clamp used to act as a vibration damper, prevent all sorts of vibrating, including orient vibration and oscillation. For the production cost for this insulator, each disc is 16 ringgit 43 cents, so the total is 197 ringgit and 60 cents. and the ball 4 ringgit, the suspension 42 ringgit, and the total production for our sweater is 342 ringgit and 12 cent. So that's all about me. I pass to my friend.
Assalamualaikum warahmatullahi wabarakatuh. My name is Hanif Hakimi bin Azlan and my matric number is CE190063. So I will continue explain about the design planning for our project. So our company has selected to develop a personal string which can pin insulation selected of 132 kV transmission line in an industrial contaminated region for this project. Suspension insulator are superior to other kind of insulator due to their greater voltage value of 132 kV than 33 kV. Suspension insulator is made out of numerous porcelain discs joined by string-like metal connection. The line connector is hung at the bottom of the suspension string, which is connected to the cross arm of the tower. So lastly, the insulation below the part of porcelain cap and pin suspension insulator. So this is our circuit for the cap and pin and insulator. So each unit or this is made to withstand a low voltage of 11 kV. The number of this in series is determined by the working voltage. If the working voltage is 132 kV, so the string will have 12 discs connected in series. Okay, next, this is the insulator prototype property option for our project for our insulator. So that voltage that we have choose is 132 kV. The type for the insulator is string. The material ceramic porcelain. For the maximum length for the 12 insulator is 1540 millimeter. For this insulator is 100 millimeter. For the conductor is 175. Piping, cap and pin insulator type is pressure. Number of cap and pin insulator is 12. Insulator length is 1200 millimeter. Weight of a unit is 8.5 kilogram. So lastly, its critical range is 4.092 meter. Okay, next we go to the location of the project. So we choose the location is at Pura Kencana, Taman Pura Kencana. So the diagram depict the position of the transmission line tower at Taman Pura Kencana, Batu Pahat, Johor. So this region is near business that do not emit much pollution and has a high density of resident with heating plant. This location also has a high density of resident and industry. Subject to strong wind and rain. Pura Kencana was then exposed to the sea pantai Sungai Lurus. So, lastly, to the conventional insulation strength, millimeter per kV chart. This project transmission line tower duration has a medium degree of position. So, that's all for me. Next, I will to explain about the FEMM software. Assalamualaikum warahmatullahi wabarakatuh. And it's Hanif Hakimi Jazlan and I'm number CE190063. So I will continue explain about the result for academic simulation. So this table is for the material that we use in our design, which is the air, steel, ceramic porcelain, water condition, and contamination condition. The relative permittivity for the air is 1, for the steel is 100, for the ceramic porcelain is 5.9, for the water condition is 80.4, for the contamination condition is 80. So each material must take its relative permittivity value to get the result. So next is the single unit ceramic porcelain. So ini insulated electrostatic analysis using the software with 11 kV testing. So this figure is the first figure is the what we call counter profile of single unit of ceramic porcelain string insulated analysis in FEMM. And the second one is the field intensity of single unit of ceramic porcelain string insulated analysis in FEMM. So the single unit ceramic porcelain string insulator design, the insulator design is available in FEMM intelligence scale, which is relative is 100 and porcelain relative is 5.9. The voltage intensity is centered on the bottom of the insulator design on the FEMM, and the voltage parameters be set to 132 kV per tree, and the ground has been placed on the upper half of the insulator. So the intensity of single unit, ceramic porcelain string insulated analysis in FEMM. The P intensity is concentrated in the center of the design between the insulated P and porcelain. Next, the elliptical potential graph is just insulator line, and is the result graph for the magnitude of electric field intensity versus insulator line. The single insulator design is not problematic since there is a little electrical field present to the insulator. Next, we continue to 12 unit of conductive insulator with SSMDC in SMM under normal condition is 136 kW per T. So what we can see is the circle for the first unit and the field intensity of first unit of sun incident. So what we can see here is the flood intensity. You can see the flood intensity under the cap and under the P. Okay, next is the result for the first unit. So the result is the result for the electrical potential graph, which is select under normal condition. So you can see here the graph decrease, and the graph for the magnitude of electricity intensity versus select under normal condition. Okay, next we go to the first unit of kinetic ceramic selected static analysis in FPNM under contamination condition with 132 kW per T. So it is the peak intensity. So like saying the flood is small, is little bit flood intensity in the upper and under insulator. Okay, next is the result for the this is the result for the contamination condition. On the FMM, the voltage density is centered on the bottom of the insulator design. The voltage parameter was set to 132 kV, and the lowest voltage intensity was there at the top of the first insulator design. The peak density of the unit of soliciting insulator in FMM under contamination condition is then shown in this circuit, this slide. So electrical potential graph, this is specialized under contamination condition graph. Under graph of magnitude of electricity intensity versus insulation line under contamination condition. Ceramic insulator are often exposed to high pollution level, such as marine industry, sun, and under equity that display their performance and the electric electricity. Insulator pollution causes an undesirable response in the form of an increase in leakage current owing to the material high pollution rate. The pressure is applied to the insulator surface and the contaminate layer images. So next we go to the test unit under water condition. Okay, this is the result for the water condition. Like same, decrease the voltage decrease. So we use the water at 30 AC in the FNM to evaluate the insulator design in water condition. The test unit ceramic insulating insulator AC in FNM under water condition. Water is put at the end of an insulator, and the effect of the insulator are evaluated. The intensity of first unit of insulating insulator under water condition. The graph for electrical potential graph is insulator line under water condition is shown in the slide. So finally, the magnitude of electric field intensity is insulator line under water condition. We can observe that even though the insulator has the same fringe pattern, the readings are different due to the water on the insulator, because water is a conductor. When it falls on the insulator, an electrical field is created at the end of the insulator cap where there is water causing an increase in electrical field strength. That's all from me. Thank you so much.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Hanafi Ali bin Ahmad Sobri, and my meeting number is CE197071. Okay, I'll be presenting for the risk assessment. Okay, for this assessment, the severity matrix. So the severity value is a potential consequence of an incident or injury given a current level of control. For 5, it's a very high. It can cause death or permanent incapacity. For 4, it stands for high, which it can cause a major injury and severe incapacity. For 3, it is moderate, which can cause injury or illness for 3 days or more. For the slide is a minor injury, which is cause illness immediate for the first aid only. And lastly is negligible, or we can call it as no injury or trivial injury. Okay, for likelihood, it is the potential of an incident or injury occurring given to the current level of control. The mostly is almost certain to occur and likely to occur. For the third one is quite possible to occur, and number 2 is not likely to occur, and the last one is is almost certain is not to occur. Okay, for the test conduct, so in this insulation resistant IR test, the only high voltage HV test is for this method is dry test only. So for the dry test, before the test begin, the voltage level of insulator need to be determined to find the suitable rating for the IR tester, which is the HV test, using the megameter. So this insulator use 132 kV high voltage, which is this 11 kV. From the table, the suitable IR rating is 5 kV. So from the table, we can see for the voltage level, 650 volt. The eye testing rating is 500 volt DC for 1.1 kV. The eye testing is 1 kV DC for 3.3 kV. The eye tester rating is 2.5 kV DC. Lastly, for 66k volt and above, the eye tester rating we use is 5 kV DC. So after the eye tester is determined, the equipment that used in the eye test, which is a megameter, need to be tested whether it's give infinity value when not connected, and the zero when the two terminals are connected. Together the handles is rotated to avoid malfunction or the equipment avoid the wrong measurement. So this is the table for the different value condition of IR test. So from the table we can see the first condition is fair to high value and a well maintained. uh, what we need to do is ignore cost for the constant. So the second one is a fair to high value, but it's showing a constant tendency toward the lower value. The third one is a low but a well maintained. So what to do is this condition is probably alright, but cause a low value should be checked. The fourth one is so low and to be unsafe. And lastly is a fair height value and previously well maintained but showing the sudden lowering. Okay, moving on. So this is the performing and insulating resistance test. The asset being tested is connected to a non-high DC voltage and the resulting current flow monitor. So the current value, which is typically very small, is transformed into an insulating resistance value using Ohm's law. So the safety and the quality of the asset insulation system can be examined by comparing its insulation resistance value which specified it can cause a pass or fail in this criteria. So additionally, by performing insulation resistance tests on asset or a regular basis, the result can be trained to identify variation, which can help detect the insulation by degradation and predict the asset remaining lifespan. So in conclusion, insulator is very important in the electrical circuit. Insulators support separate electrical wire in electrical equipment without allowing current to flow through them. Insulation is about insulating substance used to wrap electrical wire and other equipment. Besides that, insulating support used to attach electric power distribution or transmission line to utility line posts and transmission tower sometimes referred to the as insulator. They bear the weight of the entangling wire while preventing electricity from flowing through the tower to the ground. Next, glass or porcelain string insulator, porcelain long ropes, and composite insulator are among the insulator available for use on overhead transmission line. There are a variety of design, material, quality, and price in each category. Okay, that's all from our group. Thank you.